Okay, this video is to cover a few things that we did not quite get through in class. And so first off, especially for period 1, we need to look at the complete correct solution for number 99 from yesterday's homework. So focusing on number 99, we're trying to isolate cosine, so we start by dividing both sides by 4. And that gives us cosine squared of x is equal to 3/4. Then we square root both sides. Now the part that I forgot during class and that caused all the confusion was whenever you are square rooting both sides, just like if this was an x squared, we have both plus and minus. It's both positive and negative, because if we square a positive, we get the same thing as if we square the negative. And the square root of 4 gives us 2. So we're looking for both places where it's positive square root of 3/2 and negative square root of 3/2 on the unit circle. So if we take a look at the unit circle, on the x-axis, here's our 1/2. Here's our square root of 2/2, square root of 3/2 is right here, so we're intersecting here, and both the negative as well in here. So these 4 points are all of the solutions in one revolution of the circle. So we've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are the 4 solutions if we're only looking at one trip around. But notice that it says from infinity to infinity, negative infinity to positive infinity. So we're looking for all of the solutions. And so each of these would get a 2 pi n. Well, in the book, it just said pi n, and it only listed 2 of these solutions. Well, what's happening here is, take, for example, if we start at pi over 6. If I add pi to it, I get to this solution here. And if I start here and add pi, I get to this solution. So it's a more compact way to write the answer. I would probably just write pi over 6 plus 2 pi n, and then 5 pi over 6 plus 2 pi n, and 7 pi over 6 plus 2 pi n, and the 11 pi over 6 plus 2 pi n. And list them all. It's just a more condensed version of the answer. What's listed in the textbook is the solution. Okay, so now to finish some of the stuff from classwork that we didn't quite get to. We left off working on number 106. So I just want to make sure that everyone's really got this down. So we went over A, we went over B. B is just the fundamental Pythagorean identity, so it equals 1. That's it. C, so looking at C, I'm going to scroll up here and take a look at some of my notes. Let's focus on C right here. Notice that the format here that we see is cosine squared of something minus sine squared of something. Well, what matches that? If I look up here, isn't that the same as what we see here? So alpha in our example here is 40. 40 degrees is what alpha is. Now this equation is saying that cosine squared of alpha minus sine squared of alpha is equal to cosine of 2 times alpha. Well, alpha is 40. So cosine of 2 times 40 happens to simplify to cosine of 80. So that's it. There's the simplified version using our rules. Okay, D. What matches problem D? Okay, well, I've seen 1 minus 2 sine squared. Okay, here we go. 1 minus 2 sine squared. That matches right there. 1 minus 2 sine squared of alpha. So what is alpha? Here's our alpha. That is alpha in part D. So this, according to this rule, this is equal to 2 cosine of 2 alpha. So we got cosine of 2 times alpha. Well, alpha is y minus 5. Let's distribute, simplify. Cosine of 2y minus 10 is our simplified version there. Okay. Moving on to E. We've got sine, cosine, cosine, sine. That's a sine shuffle. I know that it's sine of alpha plus beta. Alpha is 30, beta is 40. So 30 plus 40. We've got sine of 70. Simplified version. And F, got matching this rule up here. Okay, so this indicates that it's equal to cosine of 2 alpha, so cosine of 2 times, what is alpha? Right here, 2w. So cosine of 4w. Okay, hope that helped. Okay, 107, how do you use the double angle formula? We didn't quite get to this one, so here's an example of when it could be used. So suppose we have this nifty little equation right here. Sine x times cosine x we know is equal to 1/4. This equation contains both a sine and a cosine. So we can use the double angle formula to simplify this so we don't have both sine and cosine. Having both is problematic. So we can rewrite this so that it's going to work out for us. So if we think about, okay, something that has sine times cosine, well, our sine double angle formula was 2 sine cosine of 1/4. So a nifty little idea here is we're always allowed to multiply both sides of an equation by the same thing. So if we multiply both sides of this by 2, we're going to get 2 sine x cosine x equals 2 times 1/4 would be 2/4, which simplifies to 1/2. So this is now matching the 2 sine cosine pattern. So now we have the fact that sine of 2x is equal to 1/2. So now we need to find all of the values where sine of something, sine of alpha, is equal to 1/2. So we're going to, as it says here, we're going to let alpha equal 2x so that we simplify this down to the question, where is sine of alpha equal to 1/2? Okay. So all of the places where sine of alpha is equal to 1/2, using our strategies with our unit circle, we can find that alpha would be pi over 6 plus 2 pi n to find all of the solutions, and also 5 pi over 6 plus 2 pi n. Okay, so we found that using our unit circle, the two places where sine is equal to positive 1/2. Okay, so alpha happens to be, as we stated before, 2x. So we're going to need to do a little bit of substitution here to finish this problem up. So alpha happens to be 2 pi, so 2x. So 2x is equal to pi over 6 plus 2 pi n. It is also equal to 5 pi over 6 plus 2 pi n. So to find the x values, we're actually dividing everything by 2 on both sides. So when we divide by 2 here, we've got x is equal to, now pi over 6 divided by 2 gives us pi over 12. 2 divided by 2, we have to actually divide both of the terms here. 2 divided by 2 leaves us with a pi n. And over here, we end up with 5 pi divided by 6, I'm sorry, 5 pi over 6 divided by 2 is the same as 5 pi over 12. Okay, if you're wondering where that 12 came from, when you're dividing by a 2, invert and multiply. Keep, change, flip. And then 2 divided by 2 simplifies there, and we've got plus pi n. So here is the complete solution for our original problem that we'd begin with up here. Okay, so there's one way that that can be used. Okay, problem 108 describes how we can use the double angle formulas to find half angle formulas for both sine and cosine. As far as I'm aware, there is not a useful half angle formula for tangent. So we're not going to deal with that. But this basically steps us through the process. So we start off with this particular cosine double angle formula, and then solve it for cosine. So subtracting 1 from both sides, and then dividing by 2. Actually adding 1 to both sides, we get this plus 1, and then divide by 2 on both sides, we get the 2 under here, and then square root both sides to undo the squared. Again, when we square root, we get a plus or minus. And then this is indicating that we're going to substitute for the 2a, we're going to substitute the theta. So in place of 2a, we're going to put theta, and that gives us this equation here. Okay, and then by using a similar process, you can derive the other one. So that's all I'm going to do with that for now. The key thing here is that you write into your notes these two half angle formulas for sine and cosine, and then also useful are these formulas that we came across in the preliminary steps. So having all of these in your notes, this one, this one, this one, and this one, are very useful, so make sure you write those clearly in your sketchbook. Okay, so one of your homework problems is going to be number 109, so I want to get us started on that. This is applying our sine double angle and cosine double angle formulas, so let's take a look at that. So we're trying to find the exact values for each of these, and this here is basically just indicating that we are in quadrant 3, like in the picture shown here. So we're given that cosine is -4/5, cosine being adjacent over hypotenuse. We can label it like this. With Pythagorean theorem, we know that this leg is -3. So using finding exact values for sine of 2x, we can use the equation that we've just learned, the formula for that. So the formula indicates that it equals 2 times the sine of alpha. Sine of alpha, or sine of x in this case, is -3/5. And then multiplied by the cosine of the angle, which is -4/5. So that means that simplifies to, let's see, 2 times 3, 624. So not negative because it's a negative times a negative, so positive 24/25. So that is the solution to our first one here. So I'm going to leave the remaining ones for you. One little note, these are supposed to be x's. So you're using the half angle formulas for that. That's not supposed to be pi. Okay, so good luck on your homework. See you tomorrow.